Hello everyone, so we're now down to our part 4. So just a simple reminder to all of you, I should expect that once pinanood nyo yung video na to, you're done with your 6 modules. Because the session is really intended for you to finish all the 6 modules kasi meron pa tayong mga ibang students dito na hindi pa rin tapos sa 6 na modules, and take note, prerequisite sila para makatake ng midterm exam. So, kahit magmakaawa pa kayo, hindi talaga kayo makakatake. Not unless tapos yung 6 na modules. Okay? So, let's continue. In our example 8 here, we are asked to evaluate the limit of 1 minus 5x all over 1 plus 3x squared plus 4x to the power 4 as x approaches 1. So, just remember from my previous reviewer, told you that it's very important to identify the function given and the c as well. So, doon may nakikita tayong variable sa denominator. Pero kapag isa-substitute natin kung ano yung c natin, in which it's 1, wala namang kaso kasi if we follow PEMDAS, denominator will turn out to be an 8. So if that's the case, you can simply substitute and think as if x is 1 because c is equal to 1. So there you go. So 1 minus 5x becomes 1 minus 5 times the quantity 1. Then sa denominator naman natin, we have 1 plus 3 times the square of 1 plus 4 times the fourth root of 1. So following PEMDAS, you'll get negative 4 in the numerator and 8 in the denominator. And once you simplify it, you'll get negative 1/2 because both are divisible by 2. So that's the limit of the function. Let's now proceed to example 9. So we're asked to evaluate the limit of square root of x as x approaches 1. So take note, our answer here would probably become greater than 1. It's because once we get the square root of a certain number, it's either 0 and higher. So kapag yung x natin magiging mas mababa pa sa 1, let's say negative 1, negative 2, once we substitute that to our square root or our radical function, it will make the limit imaginary. So to continue, our c here is 1. So substitute, and then that will become square root of the limit of x as x approaches 1. So take note, kapag yung binigay sa atin is radical function, do not mind the radical yet. So think as if you just have to get the limit of the x, the ones inside the square root, applying radical or root rule. The limit of x as x approaches 1 is just 1. And then that's the time that you get the square root of its limit. Square root of 1 is 1. So that's the answer. Okay, let's proceed to example 10. So how about the square root of x plus 4, if that's our function, and our c would become 0. So we're asked to find the limit of square root of x plus 4 as x approaches 0. So our c here is 0 and our function is radical. So probably you'll be using radical or root rule for this one. So since c is just 0, so we can immediately substitute 0 to our radical function. That will become, yes, you can simply substitute it inside and find its limit. So 0 plus 4 is simply 4. That's the limit. And then you get the square root of it. Square root of 4 is just 2. I-remove ko lang yung handwritings or markings. Let's continue. Example 11. So we are asked to evaluate the limit of cube root of x squared plus 3x minus 6 as x approaches negative 2. So still it's under radical or root function. So probably yung gagamitin natin na rule under limit theorems would be radical rule. So to consider radical rule, we just have to find the limit of what is inside our cube root. So that's x squared plus 3x minus 6, where our c is negative 2. So you immediately substitute that to the function x squared plus 3x minus 6. So that would become negative 2 squared. Negative 2 squared is 4. 3 times negative 2 is negative 6. Then we have a constant term at the very end, minus 6. So you just have to follow PEMDAS. For minus 6 is negative 8. Okay, now, since we're talking about cube root, that means a certain number that can be multiplied by itself 3 times. So once we have negative 8, you can think of negative 2. So this is some contradiction to what I've said a while ago, that it must be 0 and higher. But since kanina kasi we're talking about square roots, but for cube roots, it's possible for us to have a negative already. Because it doesn't mean that it's negative, then you cannot think of 3 numbers or a number multiplied by itself 3 times will result to that negative number. So for this one, negative 8, negative 2 times negative 2 times negative 2. If you multiply 2 negative 2's, you'll get 4. Multiplied by negative 2, you'll get negative 8. So the result is negative 2. So that's the limit of this function. Okay, we're now down to example 12. So in our example 12 here, we're asked to evaluate the limit of square root of 2x plus 5 all over 1 minus 3x as x approaches 2. So our c here is 2. In other words, x is 2. That's what we need to consider once we ought to use the method through algebraic expressions, or our usual process before when we deal with expressions. So first, since we're talking about quotient here because of the fraction bar, that means we will apply quotient rule. Once we apply quotient rule, you find the limit of what is in the numerator, that's the square root of 2x plus 5, and then you also find the limit of what is in the denominator, which is 1 minus 3x. So if we deal with the ones in the numerator, you will notice that we will apply the radical rule. So applying that rule means that you have to find the limit of the 2x plus 5. So do not mind the square root yet. So after you find its limit, that's the time that we deal with the square root. While in the denominator, we can immediately substitute 2 to the x because it will not end up to a possibility na meron tayong 0 sa denominator. So wala namang possibility magiging undefined siya. So okay lang mag-substitute ka agad. So that would be 1 minus 3 times 2. You'll get negative 5. And finally, we go back to the numerator. The limit of 2x plus 5 as x approaches 2 is 9. So once we substitute 2 to x, so that's 2 times 2 plus 5. You'll get 9. Then, as I said, that's the time that you deal with the square root. The square root of 9 is just 3. Then you just put together 3 and the result a while ago in the denominator, which is negative 5. So you'll get negative 3/5. Now, we're now down to infinite limits. So we have here certain illustration for us to picture out what will happen every time that our answer for a certain function would be infinite. It's either negative infinite or positive infinity. So 2 ways, but the given function is 1 over x squared. So once we opt to use table of values, you select values that are near to the c. And for now, we're talking about x is equal to 0. So in other words, choose x values which are lesser than that. What are these numbers? So take note, once you use this, always remember to choose numbers that are very near to it. So like for example, you can start with negative 0.0001, then negative 001, negative 0.01, negative 0.1, negative 0.5, negative 0.9. So in that manner, it's easier for us to observe the trend, for us to figure out what's the limit. And by the way, we're talking about lesser than 0, so that means this is the left-hand limit. And once you use your calculator and substitute the following values of x, you will be getting the following f of x. Okay. Then ano ba yung manonotice natin? So, as the x value approaches 0, the more that the f of x approaches what? So, we're not really certain because it increases time to time. Okay? But one thing that we've noticed that it becomes bigger and bigger going to the positive infinity. So we really don't know what's the very end. So the more that we continue, the more that it becomes smaller than this, bigger, bigger than this. So it's already 100 million. So kung gagawin pa natin yung negative 0.00001, so mas magiging mas malaki yung ating f of x. So we can conclude that we don't know where is it approaching, but rest assured that it's going to the positive infinity. So the left-hand limit is positive infinity. Now, if you look at the graph is also here. That's the second method. Looking at it, if you start from the leftmost part of the graph, going to the right, you will notice that as you approaches this part, the more that you continue this, it gets closer and closer to 0, but actually it never touches it. Okay? But the trend will always go up. So therefore, we can conclude that we don't know the y value of our function if x is 0, but we know that the values will closely approach the positive infinity. So that's the left-hand limit if we base it from the graph. Let me remove the markings. So kung doon naman tayo titingin sa right-hand limit, that means values that are greater than 0. So choose x values that are close to 0, not very far from it, so to easily identify the trend. So we can start at 0.0001. The next would be 0.001, 0.01, 0.1, 0.5, 0.9. So just take note if you are asked to find what is the f of x, you just have to substitute it in our given function for you to find the following. So what do we notice now? As we approaches 0 from the right, meaning yung mga positive values natin going to 0, what's the trend of our f of x? So it becomes, so originally it's from 1.2345679, then it becomes 4. So as we get closer, it becomes 100, 10,000, 1 million, 100 million. So if we still continue this, having a number near to 0, the more that it gets closer, the more that it becomes bigger yung ating f of x natin. We don't know kung ano ba talaga yung, kumbaga, saan siya papunta na value for f of x. So we can just make a conclusion that it goes infinitely to positive. So that's our right-hand limit, positive infinity. Okay. So, quick recap lang yung left-hand limit natin kanina, positive infinity, and right-hand limit is positive infinity. So, review lang natin konti yung graph and tingnan natin kung ano naman yung right-hand limit based from the graph. So, parang same lang din naman. You'll start to the right, going to the left. But you'll notice that as you get closer to the zero from the right, it goes up. And it will show you that it gets closer and closer to the y-axis itself, where x is 0. But the problem is it will never touch it. Okay, that's the reality, by the way. So in other words, we can just simply conclude that it goes to the positive infinity. So that's why the right-hand limit is positive infinity. So it's really, in the test, no, it's really both. You will be forced to find the limit of a certain function by using graph because the graph is given to you, but the function is not given. So you really don't have a choice. So make sure that you understood how to find the limit given the graph only. And also, there's some item that you're really forced to use table of values because again, you're not given with the function, but you're just given with the table of values and you need to observe the trend. So make sure you understand both. I know that if you will use the algebraic way, it's easier. Alright? So now going back. Since the right hand limit and the left hand limit, so the limit of the function itself is what? Since they're both the same, we can simply conclude that the limit of f of x as x approaches 0 is positive infinity. So we have here another example. So what if we'll just have to make it a negative. Yung ating function kanina na 1 over x squared, so magiging negative lang siya. So kung naging negative siya, so parang reflection lang siya from our x-axis going to our, not x-axis, I mean, the upper part of the x-axis and the lower part of the x-axis. So ito yung graph. So perhaps you can start with the graph to be fair with the other method. So looking at the trend, kung left-hand limit yung hahanapin natin, you'll start from the leftmost and you get closer and closer to 0 and notice that it goes infinitely here. It seems like it will touch the y-axis but it will never. So the left-hand limit, as we notice, it goes infinitely to the negative numbers. So yung sagot natin, negative infinity. So right-hand limit naman, same process, but you start on the right, and as you get closer to the 0, as you get closer to the x value, which is 0, the f of x goes smaller and smaller. But it will never touch this y-axis. So the trend is still going down, so going to the negative numbers, so negative infinity. So as other option, I know that we can already figure out the limit of the function itself by simply having both answers. But let's try to verify it using table of values. So we also have here the table. So first, consider values that are lesser than 0. So that's left-hand limit. Notice that the trend is similar to what we have concluded based from the graph, that it goes smaller and smaller. So from negative 4 down to negative 100 million. And if we still choose a certain x value which is more closer to 0, so mas maliit yung ating f of x. So therefore, ano yung makukonclude natin dyan? It would be negative infinity. So I will not be showing anymore the table of values for positive. Not positive. Yes, positive. X values that are positive because greater than 0. That will lead us to our answer for the right-hand limit. But if you do that, you'll still get negative infinity. So our left-hand limit and right-hand limit are both the same. So therefore, our limit of f of x as x approaches 0, doon na pala tayo sa baba. Doon tayo sa baba. So we can conclude that since both right-hand limit and left-hand limit are the same, so the limit of f of x as x approaches 0 is negative infinity. Okay, so let's consider another example. We have here f of x is equal to 1 over x. So we're not asked to find its limit as x approaches 0. So siguro graph tayo, no? If you will just base it from the graph, ito yung graph natin. So you'll start from the leftmost part of the graph going to the right. So we will observe the trend as it approaches x is equal to 0. But you'll notice that as you move to the right, from the left, gets closer and closer to 0, but the f of x, it gets smaller and smaller. But it never touches the y-axis. So that means that the left-hand limit is negative infinity. While the right-hand limit, as we start from the right going to the left, the more that we get closer to x is equal to 0, what happens to the f of x? It gets higher. But it never touches the y-axis. So, conclusion is positive infinity. So that's our right-hand limit. Then since left-hand limit and the right-hand limit doesn't exist, or not the same, so our conclusion is D and E, or does not exist. So take note that you do not put an equal sign in between here. Because if you put an equal sign, the D and E somehow tell us that it's a value. Where in fact it is not a value. But it's a conclusion where we say that there's no number that exists that would answer the limit of our function. Alright, so that ends our part 4. So please watch the next video, part 5.